Hi, I'm Paul. Let's do a quick Leetcode solution. Here's the problem. It's called factorial trailing zeros given an integer n. Return the number of trailing zeros in n factorial. Okay, this is rated as a medium level challenge. It's probably, I don't know, maybe on the low end of medium, but there are some examples here. Too simple to really spend much time with. If n is 5, for example, 5 factorial is 120, and there's one trailing zero. All right, the solution to this depends on a couple of observations. One is that trailing zeros are created by the product of the factors 2 and 5. Now, the factorial of any number is going to have more factors of 2 than factors of 5 because every even number has a factor of 2. So really the determining factor, so to speak, in how many trailing zeros there's going to be would be how many factors of 5 are in the factorial. So, you know, in this case, in this example here, n equals 5, there's one number with a factor of 5, and that's 5. So there's one trailing zero. What if we did 10? If we did 10, there'd be two trailing zeros. Same with 11, 12, 13, 14. We get to 15. Now there's going to be three trailing zeros. What about 20? Four trailing zeros. 25. Uh-oh. See, now we have a problem. The second observation is 25 has two factors of 5. All right, so we have to account for that. We have to account for numbers that have an extra factor of 5, 25, 125, 625. So let's look at the code. Here's what we're going to do. Initialize the count to 0. We will start with I equaling 5 and divide the factorial number n by 5, integer division. If it's greater than or equal to 1, then we'll add that number to the count. However many times 5 will go into n, we'll add that to the count right here. Now, the next time through the loop, we are going to multiply I times 5. That means the second time through the loop, I is going to be 25. And then we'll divide n by 25 to see if we have any additional powers any additional powers of 5, and we'll add those. And we'll keep doing this until we get a number that's bigger than n, and that's it. It's based on the number of factors of 5 and the fact that some numbers have more than one factor of 5. So let's try and, I don't know, we can run it first and make sure it compiles. Okay, that's fine, and submit it. All right. And that's it. Hope you enjoyed it. Feel free to give it a like, and see you next time.